Magnetic fields are everywhere. Our brain generates a magnetic field, although they are extremely weak to detect. Magnetic fields are generated by the Earth, are generated in neutron stars, but we can generate magnetic field in artificial way to values that are not possible elsewhere in the Earth, naturally in the Earth.
I can give you three very different sectors which utilize high magnetic fields. The first is energy and fusion energy. The second is basic fundamental science and CERN. And the third is magnetic resonance imaging, MRI, which detects serious diseases.
These magnetic fields are created by essentially a big coil of wire and running a current through that. That might be a conventional piece of wire that we all kind of know, or it might be a superconducting magnet.
High magnetic fields is quite open to interpretation, because for some people a high magnetic field might be 5 Tesla, and Tesla is the measurement that we use for the strength of a magnetic field. So a typical MRI body scanner today would be 3 Tesla, for example. But in physics research, we want to use higher fields because that starts to act on the materials to unlock their basic physical properties. So we might be into 14, 15, 16 Tesla, and eventually going up beyond superconducting magnets, which end at maybe 20 Tesla, into 30, 40, and even above. So the application of magnetic fields tells you different things at different levels about a piece of material.
It's not obvious, but many of the most interesting materials are the ones with the strongest interactions, because those are the ones that will work at the kind of temperatures we want them to work at room temperature, for example, if we want to exploit them for technological reasons. And so then you really need a high field to overcome those interactions, set the magnetic moments and the electrons in motion to be able to measure something that you can then use to understand what those interactions are, which direction they're pointing in, and what's causing them, in order to help you figure out why your material behaves the way it does.
So if you could argue I can do it with X-ray or with laser, but as soon as you expose these materials to radiation or laser, you destroy it. So you lose the information. So magnetic field is very critical to probe matter without interfering with the integrity of that material, and that's unique. You can't get it any other way. Hence the MRI body scanners. So in MRI body scanner, in magnetic field, you can have thousands of images without any side effects. Imagine you have to have thousands of these images in X-ray. You are advised not to take more, 1 or 2 in one go. So you could see the benefit is enormous in enabling us to get this extra mile of knowledge and performance not possible any other way.